Well, hi everyone. Welcome to day 3 of our Cohere AI Hack workshop series. Today, we're very excited to have Shamsuddin Azan Mohammed, the co-founder of Aurora Data Science Academy, with us to give a presentation on sentiment analysis for African languages. And it's a big honor. Thank you, Shamsuddin, for being here. The floor is yours.
Right. Thank you, Teji. I'm excited as well to be here and present our work on sentiment analysis for African languages. My name is Shamsuddin Mohammed, and a PhD student at the University of Porto, Portugal. Also a teaching staff at Bayer University, active member of Masakani NLP, House NLP, and Ariwa Data Science as co-founder. In this talk, what I will be doing is I will talk to us about why we need sentiment analysis to motivate the reason why, and also to discuss sentiment analysis for low resource languages, and finally to discuss AfriSenti sentiment semeable shared text we organized. We recently conclude and present what are the best approaches we found out, to solve sentiment analysis problem in African languages. So let's get started. So why sentiment analysis? So before we see the reason why we do sentiment analysis, let me start with a basic example of why we need a computational approach to solve some of our traditional problems. If we look at sometimes, language we know is rich and diverse. You may find yourself in a community or in a situation where you don't actually speak a particular language, and you need to employ the service of translator, service of interpreter. But actually, it's time consuming, this stuff, to translate. If you have huge document to translate them, it's time consuming. And in fact, we all know translation is, expensive and interpreter, and of course, there is no confidentiality. You need to give you a document whatsoever it is, no matter how level of confidentiality you need to give somebody if you don't understand the language to translate it for you. I believe we all know these, issues. And now, officially, we now have a computational way to, translate document. We can use Google Doc. We can use, in fact, not only translation of text, but now we can use, computational ways, many applications, to automatically translate our voice and whatsoever. And we can see here with this machine translation and, with this approach is no longer, expensive. The speed, you can translate, millions of documents in a couple of, hours or minutes. And of course, not expensive. So this is a basic something we all know, machine translation, MT, everyone knows, MT is very important, right? But someone, obviously, you may heard of sentiment analysis, why do we need this? So let's see why sentiment analysis also the same thing. We can see here, this is what we call a review. So why do we this? So, in business, people write their experience about a product. This is called a review. And we can see this guy, he had a negative experience when he bought a stuff, and someone would just go and comment, this item is not good, don't buy it, right? But the problem is when a business leaves this kind of review in their website or whatsoever, for example, in Amazon, anybody that comes to buy this item, will no longer buy this because he will see a negative review. And not only that, that person will now pass this information he saw, because we saw people tend share negative information and it travels faster. This is what we call, in psychology, what we call negative bias, meaning, human tend to pay more attention to negative information. If it is something positive somebody wrote, this is good product, it will not even, nobody will care to transmit that information, but negative information travel faster. So this means that businesses need to find a computational way. So as I gave an example, people need to find a better way to translate document, right? Rather than to, depends on translators. So the same way, businesses need to find a better way to, find opinion of people, because you can see a product with millions of reviews, 10,000, 20,000, right? The traditional brick and mortar business of, collecting informations is using survey. So people will share a survey, hey, give information about my product, but this is not a scalable situation, scalable result, because now we have tons of reviews, many information online, on social media, different places on YouTube. People need to find a better way, a computational approach to solve this kind of problem. So we can see survey, similar to machine translation, is time consuming, expensive to administer, may not provide accurate representation of the population. So for example, if I'm selling stuff, I just share, a survey with some of my client, it may not actually capture the, right people. And this leads to another bias. We saw negative bias, which is called statistical bias. A statistical bias is, a kind of bias that, I show that the amount of data you have is not sufficient to, drive conclusion. So, businesses need to find a better way. And this better way business need to find is what we call sentiment analysis. So sentiment analysis is a computational ways to automatically find opinion or emotion, of people in a given text. It also moves opinion not only on text, also now we have what we call multimodal sentiment analysis using image and finance. So this is something that nowadays people do, not only sentiment analysis on text, but also sentiment analysis on, images and other stuff. So you can see here, this is an example of review. Somebody, something smells amazing, is positive review. A decent purchase, neutral, because we can just see a decent purchase, doesn't say anything positive, doesn't say anything negative, right? An absolute waste of money, this is really negative, right? So we can see now, how can we have, automate process to find this information computationally? That's sentiment analysis system. So you can see here we have sentiment analyzer, whatsoever the system is that try to find automatic opinion of the product. Sentiment analysis has been used in many aspects, politics, education, marketing, customer service, product, social media monitoring. For example, in Facebook, in Twitter, you can use, Twitter to try to find out, how people perceive a particular, government, entities, and also business, customer, e-governance. So all of these stuff, sentiment analysis have been applied in all these different aspects. So we can see it's quite, not only on one sector, but different angles. But now all the examples I gave you here, we can see they are example in English, it smells good, quite decent, absolute money. But the question is, can we do sentiment analysis on African languages, in low resource African languages? That's the aim, our own works trying to promote sentiment analysis on African languages, low resource languages. But before we go and see, sentiment analysis on these African languages, let's see some of the, problems that, these languages face. African languages, approximately we have 2,000 African languages, however, in NLP community, in literature, they are lag behind. One of the things we can see here, underrepresentation of African languages in natural language processing. So what is this? This is ACL 2020, and in the list of, we can see 25 countries with most submissions of system. However, the dominance, there is no single African countries in this. So African languages, researchers sleeping, they don't practice, participate in this kind of research in NLP community. No, there are many problems why African researchers you haven't seen here, which we'll see here. But not only African languages, you can see from the top, some languages actually dominate the research arena. You can see we have China, US, British. So you can see the German. So you can see the countries that even dominate, research in NLP. They are, well-developed countries. But you can see Brazil at the end. We have with 8 submissions. So let's look at again, yeah, so this is also another some problem with ACLE NLP. So it's a problem that cut across all the AI and machine learning and NLP research. African languages are left behind, and they don't actually have any publication related to that. So why is that? So what is the main blocker for African NLP researchers? So one of the main blocker for African NLP researchers is that we do have talents for African continent, and the only blocker is we don't have the right AI education. We have fewer AI researchers and also lack of funding. So these two things, non-availability of AI, experts and lack of funding, these are the main blockers for AI to shine, to, African researchers to participate in AI community. But nowadays, recently, we have, a kind of change in this, problem. If we look at now different community, we have AI research community, we have deep in learning endeavor, we have Black in AI, and in fact, we can see now there are different, master's degree in AI, for example, from AIMS, we can see communities, Masakani, AI Saturday, data science, House NLP, all these communities, they are trying to, support and, support people to be, expert in AI and not only in NLP and whatsoever. So we can see the problem we have, fewer AI researchers is now, becoming, not quite a problem, but, because we now do have, people getting into AI research, but still we have lack of funding because you cannot do anything AI, you cannot do any machine learning, NLP research without funding, without data set. So this means that in African NLP researchers, they also suffer, suffer from availability of data set they can use for their own research. And this problem still persists. That is one of the main blockers for people they are not engaged in research. If you look at this, Landfrica, which is a database that, house data set for African languages. When you did a quick search, you can see for all those, 2,000 African languages, there are only 7 data set available for sentiment analysis in African languages. You can see this is kind of, this disparity is quite, alarming. I mean, of course, you not see research in because, we have fewer data set, and some of these data set, to make it worse, they are translated. So for example, you see a data set in sentiment analysis, but it was translated from English to African languages, which also introduced some kind of bias, as we will see. So if you look at this one here, sentiment analysis from Landfrica, you can see we have very few sentiment analysis data set, but for MT machine translation, we know MT is quite robust. You can see we have many data sets to do that, and we have many researchers, but for sentiment analysis, you can see they are quite very few. So this is one of the, problem, but thank God now we have many funding coming to African researchers to support their research. We have Lacuna Fund, which basically comes to, to actually support African languages, low resource languages to develop, data sets for, to solve African problem. We can see lacuna, which is basically a gap. So they are trying to, they are trying to solve such kind of gap by bridging this kind of lacuna. And our team basically, are these numbers really few or just, yeah. So I basically did a search in Landfrica, and if you go to Landfrica, because they house this kind of data set. So if you go to Landfrica and you select sentiment analysis, these are the figures I found. So yeah. So, our project, Niger Senti, which is sentiment analysis for African languages, was supported by Lacuna. Our project AfriHate, which is hate speech for African language, was supported by Lacuna. And also we recently conclude AfriSenti Semable, which is basically Semable, competition for sentiment analysis in African languages, is also supported in some ways by Lacuna Fund. So we can see Lacuna Fund is actually trying to, bridge the gap by allowing Africans to create African data set, which would also, fuel research in African languages. And thanks to Lacuna for, that. All right. So that is, some of the problem we have in African languages, lack of availability of data set, which, stop us from doing research. But now we thank God we have, few data set, we can do that. So we started with adjacency, because if you want to solve problems, start with small problem, right? So when you solve a small problem, then you can expand to, do a lot more. So what we did, we start with adjacency, which is basically a sentiment analysis in Nigerian languages. And we basically, successfully, conducted the research, and you can see it's a lot of collaborative work with different people, those that speak language expert, and also people from the community. We did a lot of contribution. We released a level data set for 4 Nigerian languages: Hausa, Igbo, Yoruba, and Pidgin. We released on level data set. The highest, on level data set in Africa, in Nigerian languages, we read that. And, we also annotate sentiment lexicons in Nigerian languages, Hausa, Yoruba, Igbo. So what is sentiment lexicons? Words that shows sentiment carrying word. For example, good is bad, all these ones, we read them. They are useful also in sentiment analysis research. And we also train various pre-trained models. We release the code and, whatsoever to promote research in sentiment analysis in Nigerian languages. So this is our first main contribution in sentiment analysis in Nigerian languages. And this contribution actually motivate us to, to work more. And we didn't actually, do any translation here. For example, as I show you, some of the data set were translated from high resource languages in African language, but we create this data set from scratch. So this is a Twitter data set. We crawl and we hire annotators and we crawl. And we annotate approximately for each language, we annotate 30,000 tweets. And so this is the largest Twitter data set available so far on any languages in African languages. So, based on also Landfrica, and this is the largest data set based on Landfrica. Now, we encountered a lot of challenges when creating this data set, and we wrote this in our paper, which people can read if you're interested, which is a Twitter academic API, emoji language detection. One of the main problem I want to talk is, Twitter supports 70 languages through their API, and only one African language is involved, which is Amharic. Among the languages that Twitter supports, there are some languages that they don't have even up to 10 million people. But in African languages, we have Swahili with more than 100 million people. So this kind of systematic bias, and inequalities actually fuel the, this kind of, non-availability of data sets. So right now, Twitter also is going into another crazy direction. From today, I think Twitter is closing their API. If you want to get Twitter data set, you need to pay. Elon Musk is doing stuff. So I was reading, if you want to get for example, people need to pay about $42,000 to get access to Twitter data set for certain numbers. And if you want to get 5,000 tweets per month, you need to pay $100. So Twitter is monetizing their data set. But thank God we got this data and whatever. So we also, conduct a lot of, analysis. One of them is code mix. We understand, Nigerians are African, not only Nigerians are, multilingual, and, all our data set are code mix. And one of the main thing I, remember is that a lot of people will say, hey, sentiment analysis is a solved problem. Can we use the approaches that have been used in English, in German, just to solve sentiment analysis, because it's no longer a problem? But African languages, we have domain context dependent. Language is dependent. Is specific to to particular community. So you cannot say the only way that you solve problem in English, you just solve it. So there are many things. So for example, tonality challenge in Igbo or Yoruba, tones actually matters in the sense that I'm not your boy here, but maybe Teju, can you help me to say these ones?
Okay. Àwọn ọmọ fọ abọ́. That's the
Yeah.
first one. Like children are washing dishes. Àwọn ọmọ ń fọ abọ́. And the other one, àwọn ọmọ fọ abọ́.
Is it the Yoruba or Pidgin?
It's Yoruba. So the second one is like four is to break. Four is to wash. It's like four and four. So that's that's what differentiates between two sentences.
So you can see only this accent, changes the sentiment of this. This is positive. This is negative. Only this. So you can see the tonality, the way somebody tones. So you can see African languages, they have their specific problem, specific, things that we need to address. So these are some of the challenges you can see we find out, and we need to develop models. We need to come, best way to deal with this kind of problem. So that's sentiment analysis problem we encountered, and there are many ways now that I would move on, not only about the data set, but computational ways, how we can, solve sentiment analysis, how we can do sentiment analysis. So we can do sentiment analysis basically using either lexicon based or machine learning or deep learning. Let me just start with the lexicon base. So how can you do sentiment analysis? So given a tweet, I love the car. What you need to do in lexicon, from the word lexicons, you try to find out what are the positive lexicon in a text, and you classify it as positive. So here, because I have love, so all these kind of word, we call them lexicon, you put them in a dictionary. So you can see this is a dictionary. And now when you have a text, for example, whatsoever, so you try to find out, does that text contain some word in positive or negative dictionary? If it is content, then you say it's positive or negative. This is sometimes called dictionary based or rule based or whatsoever. But this is not scalable solution. It doesn't work in all situation, because you can see this one, his pain, for example, here we have the stock price is increasing. This is positive in which domain, economic or whatsoever domain. But we can see here, you say his pain is increasing in, medical domain, his pain is negative. He is mad programmer, in nowadays, because the word mad changes from negative to positive. Mad program means excellent or good program in some ways. So lexical-based sentiment analysis cannot be used effectively to solve sentiment analysis problem. We need a better way. Thank God now we have many approaches, and these approaches has been used in our low resource African languages because they don't have data set, they have lexicons. So we can see here, for example, this is a paper, they use lexicon base, they translate the lexicon. Another one here also, they use lexicon, they translate lexicon, but lexicon based sentiment analysis or translations alter, sentiment of a word. So for example, this paper, what they did is they take a lexicon in one language, in English, and they translate the lexicon into Igbo, and they did sentiment analysis. The problem is this sentiment translation alter sentiment. So let me show you an example. Here, this is something someone, wrote in Facebook in Hausa, mashallah, Allah ya azurtani da samin karuwa da tanamiji. Somebody is, saying he was happy his, wife gave birth to a baby. But you can see when the Facebook did a translation, may Allah bless me with getting my prostitute. So you can see the translation changes to something negative. You can see prostitute, so we can see, it changes the sentiment from positive to negative. So translation actually alters sentiment. So we need a very good data set, that is, created from scratch that allow us, to do sentiment analysis. And, lexicon based, as we can see, is now a better way. And we can use machine learning and deep learning approach now to do sentiment analysis, which actually, take care of context, because deep learning now is contextual embeddings. This is what you're going to be doing with Cohere AI. They will provide you with embeddings. Those embeddings are contextual. They will learn the context. When you say, for example, here, Karua. So in Hausa, this word Arua, it can means, give birth. If you put it in another way, Karua, it means prostitute. So embeddings allows you to know what context a word is used, and it will apply, the correct word. And Cohere AI will give you access to their embeddings. Then you can exploit that embedding to solve many problems. One of the one of the things you can do sentiment analysis is embeddings and whatsoever. But yeah, so this is just, what you can do. So let me now take you to some of the, solutions we built on sentiment classification using NigerSenti. So we did a bunch of experiments using, pre-trained language models. You can see we use multilingual pre-trained language models, MBAT, SLMR, AfriBata. We use, language adaptive fine-tuning. We use multitask. We use zero-shot cross-lingual transfer. These are all approaches to solve problems. So let's look at this, the first one. So the first one is called multilingual pre-trained language fine-tuning. So what is the meaning of fine-tuning? So nowadays, fine-tuning is the gold standard. I mean, it's the first thing you do when you want to solve, deep learning or NLP problem. What is the meaning of fine-tuning? So some of us may not be familiar with what fine-tuning is. So if you want to solve a problem, you take a pre-trained language model, right? Example, BART, GPT, or whatsoever, and fine-tune it on relevant task data, and you use your classification. That's what we did the first one. We took, all of these pre-trained language models, MBAT, SLMR, AfriBata, MDBata, and REMBata, and we fine-tune them, meaning we use, another data to fine-tune to relevant tasks. And these are some of the results. So you can see here, we have multilingual pre-trained language models. We have AfriBata, MBAT, SLMR. And, these pre-trained language models, they have been pre-trained on several languages. We can see here, AfriBata was trained on 4 Nigerian languages. MBAT was pre-trained on Yoruba only. SLMR was pre-trained on Hausa only. And MDBata was not pre-trained on any Nigerian languages, and REMBAT was trained on these languages. And we can see the, performance of these models. We can see that AfriBata actually performs better and is the winner. Why? Because AfriBata is a small model, but was pre-trained on Nigerian languages. So it means AfriBata has seen Nigerian languages and it performs better. However, we can see also, MDBata, which was not trained at all. It hasn't seen any Nigerian languages, but it performed closely to, AfriBata, rather even much better than REMBata, which was also, which has seen Hausa, Igbo, and Yoruba. And this is impressive performance. This is basically what we did with fine-tuning. But can we do better than just normally fine-tuning? Yes. That is what we call continual pre-training. There's a question, what makes MDBata performs better? So even though it was not pre-trained, on African languages. So what make it better? So we actually don't know what makes MDBata makes it better, but maybe it relates to pre-training. MDBata actually make use what we call, replace token detection, which has shown impressive performance also in English and many other tasks. We are not sure, so maybe the pre-training, code mix and Igbo tweets. But also other languages, they also have code mix, right? For example, right. So if we go back here, yes, maybe it is give us, if you go back here, which I made mention, we can see here, we have our tweets. We can see here, Igbo. The tweets are basically code mix, maybe 50%. Can we see that? 50% of either tweet are, code mix, meaning 43%, I think they are, code mix, and, only 57, they are monolingual, meaning that code mix, it means it contains English and Igbo. And we can see that and MDVATA was basically trained on English and many other languages. So maybe this explains some of the performance of MDVATA on Igbo, but not, but in fact, also we can see it consistently across, Hausa, even though Hausa does not have a very large amount of code mix, it has 79, better than, MBAT, which has seen, XLMR, which has seen Hausa in training. So yeah, but I think, this can explain why MDBATA was also, good, but consistently, MDBATA, you can see it performs better. And so can we do better than just fine tuning? So here is fine tuning the same as transfer? Yeah, so this is a good question. Somebody is saying, is fine tuning the same as transfer learning? Yeah, that's transfer learning. So what does this mean? Now here is pre-training. You train a language model, which we call pre-training, on level data. Very large amount of data. You train a language model, and now, you fine tune, which also transfer learning on tax data. So if you are doing sentiment or machine translation, so this is typically what we call transfer learning. Yeah, you are right. Okay, so yeah, can we do better than just fine tuning? Yes, we can do what we call continual pre-training, and this has been proven to be an effective way to actually solve, problem, to continue pre-training models rather than just using fine tuning. So this is one paper that do that. So what is free continual training? Sometimes continual pre-training is called adaptive fine tuning. So these are two terms that you find them in academic, interchangeably used. So what is the idea about this? So you have pre-trained model trained on large data. And now, for example, here, we can see here SLMR was only trained on Hausa, right? It has not been trained on Igbo, Yoruba, and whatsoever. Now, I can take any pre-trained model. Now I continue pre-training it, not only fine-tuning. So it means now there is two pre-training. The first pre-training, then there is another pre-training. So this pre-training that you continue, you also get a very large corpus in a particular language. So for example, let me give an example. Here I have MDVATA, which was not trained on Hausa, Yoruba, or Igbo. Now, if I want to do continual pre-training, I need to get a corpus for Hausa, Yoruba, and Igbo, and take MDVATA and continue pre-training it. That is called adaptive pre-training or adaptive fine-tuning. So that thing will actually has been shown to, increase performance. And finally, you can do fine-tuning. So we have three different kinds of adaptive pre-training. We have language adaptive pre-training. Language adaptive pre-training is that if a language model has been trained on English and you want to transfer it to Hausa, then I need to get more data on Hausa and continue pre-training on it. That is called language adaptive pre-training. But also there is what is called TAP adaptive pre-training, and this is called LAT. That is also called task adaptive pre-training. So if I want to do sentiment analysis and I have pre-trained language model, for example, BAT. Now, if I want to do sentiment analysis, then I need to take my training data for sentiment analysis, training data, and continue pre-training on training data. That is called task adaptive pre-training. So you continue pre-training on the task data. There is also domain adaptive pre-training. So for example, here I have a BAT, which was trained on a general corpus. Now I want to apply BAT on medical field. Now what you need to do is get some more data on medical field and do continual pre-training. That is what we call domain adaptive pre-training. So we have three kinds of adaptive pre-training: language adaptive pre-training, task adaptive pre-training, and domain adaptive pre-training. So what we did is we did what we call language adaptive pre-training. And we can see here, we can see here, we did language adaptive pre-training left. So for example, we take MBAT and SLMR. So we take two pre-trained language model and we continue training. And we use general corpus, and we use domain-specific tweet corpus. And as you can see here, we use the left here, 81.5. You can see here the performance here, SLMR was a winner using left. But we use general corpus here, not tweet corpus. And the general corpus, the main reason is that the general corpus we use here is large enough. That is why the performance increased. So that is multilingual pre-trained language model for us left. And yeah, now we sit down and say, okay, now we solve Nigerian problem. We create corpus for Nigerian sentiment. Can we do better? Can we extend Niger sentiment to, maybe Afri sentiment? Yes. So that's what we do. We extend Nigerian sentiment analysis corpus to Africa sentiment analysis corpus. And not only that, we organize what we call a shared task or a competition that tries to, we try to invite other researchers, not only from Africa, but researchers from, around the globe, from China, from Germany, from US. We invite them to compete to try to solve sentiment analysis problem that only, African languages. And yes, so we have a question. Will you have to do this adaptive pre-train on each language or all of them at once? Why use MBAT as pre-train model and not MBAT? Oh yeah, so this is a good question. Why we didn't use MDBAT? So MDBAT, they didn't release their code at that time, it's closed, but MBAT was open. So anyone can use MBAT. SLMR also was open. You can use MDBAT, I believe from Facebook, Meta, right? So at that point, MDBAT was closed. So there is it's not available that we can do pre-continual training on it. So what is SEMAble? So SEMAble is basically a shared task or competition that try to solve, sentiment or semantic evaluation. Is different from other competition such as, Zindi or Kaggle, in the sense that this is ACL based, workshop where when you participate, you write a paper, you attend a conference, and you can meet people and discuss. And you can see SEMAble has been in existence since '98, and you can see it has been in existence, but there wasn't any African languages. And our own task, SEMAble for sentiment analysis for African languages, was the first competition that involved African languages in SEMAble. And you can see here SEMAble. And since 2013, there are many sentiment analysis. All these guys, they are in English. You can see them 20. Consistently, in SEMAble, there are sentiment analysis or related tags on English, on shared tag, but there isn't anyone for African language. And our own shared tags, SEMAble, try to, break this monopoly, So we have SEMAble and try to do that. And, why do we, promote this? Promote SEMAble, try to solve African, promote NLP research in African languages, for student opportunity for them to write paper, attend a conference. And of course, we put, award for best people, best system. We have 5,000 USD for best system, and also we have best paper award. And you can see this is, the languages. We have 12 languages. You have different subtasks, multilingual, monolingual. We have zero shot. And the SEMAble, workshop will be co-located in ACL 2023 in Canada, Toronto. And, we receive a lot of submission from different teams. So you can see this, some of the languages we have, Hausa up to Oromo. We have monolingual, we have multilingual, we have zero shot. And these are the subtasks we have. And we receive a lot of submissions in our system. We have over 500 submissions, people trying to solve the problem. And among these people that participate, some of them wrote a paper. So we received 29 papers. So people wrote a paper describing their system. They submitted to the workshop. And now, they will attend the conference in Canada. Now, previously, you saw that we show that actually in those days, previously, AfriBata was base system, right? AfriBata 1 here, you can see AfriBata. At this point in time, it was only pre-trained language model on African languages, AfriBata. But now, after Niger Senti in our AfriSenti, there is a new model called Afro SLMR. Now, what is Afro SLMR? if you can see here, as I showed you here in our AfriCenti and adjacency, SLMR plus LAFT, language adaptive pre-training, achieve a very good performance, right? Now, this shows that if we scale SLMR, we do adaptive pre-training with more data, because this is a few data. If we can train SLMR with very large amount of data, it can perform across African languages better than AfriBata. And this is what happened. So Jesse Joba and David, they took this further. They do continual pre-training on SLMR with more data. And now Afro SLMR is the best system that perform well on different tags on African languages. And this evidence comes from our shared tags, where many participants that participate, the best system was basically on Afro SLMR. As you can see here, we have many systems. There's top system, we can have NLND, you can see we have subtax B, we have subtax C, these are the system. And all these, system, these teams across, they do Afro SLMR. Let me tell you one interesting things that this winning system did. So these are some of the teams, you can see them. Bosch Center for Artificial Intelligence in Germany. We have Field Life Insurance from China. We have these guys from Luxembourg and Morocco. We have this LISAC, which is from Faculty of Science, Morocco. We have George Mason University from US. We have Howard University from US. These are some of the few systems that stand out, but we have about 29 of them. Please read our paper, AfriCenti Semable. It is there. We have explained all the system, and you can learn more about them. So these are the systems, but the question is, how they won their system, how their system won. So if you look at this NLND, I already told you about adaptive pre-training, right? So all of the continual pre-training, all these systems that stand out, what they were doing, they are doing continual pre-training. Can you see continue pre-training, continue pre-training, continue adaptive. So this means that to solve African problem, what you need to do is just do continual pre-training. Don't stop pre-training. Do continual pre-training. The best system, which is NLND, let me show you what they did. This is the best system across our shared tags. No language, no data expertise. So they call their team NLND. They don't know the language. They don't speak Hausa. They don't speak Yoruba. But we have people that are Yoruba. We have people that are Yoruba in Hausas, but they were not able to, beat these guys. They are from Germany, Bosch Center. But what they did, this is what they did. First, they did LAFT. What is LAFT? Continue pre-training on language. So they take Afro SLMR, which I told you was the best now language pre-trained language model. They took SLMR, Afro SLMR. They do another LAFT. They get more data. They do LAFT. That's the first thing they did. So when they did LAFT, it means their model now understand more about these languages, African languages. But they did the LAFT with more African languages. Now they did only LAFT. If you remember, the Afro SLMR, what they did is only LAFT. They did only LAFT, language adaptive pre-training. But I also told you we have another kind of another stuff which is called not LAFT, but we have what we call task adaptive pre-training, TAPT. What is task adaptive pre-training? When I want to do sentiment analysis, I have my training data. I will take that training data and now do continual pre-training on it. That is TAPT, task adaptive pre-training. So what this team does is that they do 2 free continual training. They did LAFT. They get more data on these African languages. They do pre-continual training. And now they do TAPT. So they combine LAFT plus TAPT on the training data we provided. And now, boom, they achieve the base system. So LAFT, we understand in conclusion, to leverage LAFT, language adaptive pre-training, and TAP will achieve best system in sentiment analysis. And we believe not only in sentiment analysis, across different kind of, tasks, NLP task will be a very competitive task. Thank you very much. And happy to answer your question if any. Yep.
Thank you very much. A virtual round of applause to you for that awesome presentation. Really learned a lot. And I was also very curious about one of those winning teams. They actually did continuous pre-training on MD Beta, I suppose. Is it now publicly available for people to use?
No. They use pre-continual on Upflow SLMR.
Ah, I thought I saw MD Beta, maybe.
No. Yeah.
Afrex.
Yeah. So all the winning teams, they did pre-continual training on Upflow SLMR.
I see.
Yeah.
Awesome. Do we have any question from the audience? So one cool thing about what Shamsuddin have just taught us about is that now you can think about using some of this, the Cohere embedding to solve problem like sentiment analysis, right? So it's just mentioned that, like, also maybe think about how to use the embeddings to better label the sentiment of a sentence to see how the performance is. And you can also maybe train your own small model by first labeling, using the large language model to label. You of course verify, and then you can now maybe fine tune your own model to see how it works and things like that. So there's really a lot of flexibility as long as you're dealing with text. I think there's a question in chat. Oh, I think the question is for the organizers, which you're also part of, Shamsuddin. So it says, is our project supposed to have multilingual embedding? Yes, essentially the model itself that you have to use if you want to qualify for the prize is the Cohere multilingual embedding API. But your project does not necessarily have to be a multilingual project, right? You could focus on one language and to solve a problem, but you have to use their multilingual embedding to solve that problem. Is that understood? Thank you for sharing more links on continual training. I will post that also on Discord so that we don't lose it on chat. Do we have any other question for Shamsuddin?
Yeah, so somebody was asking, can you explain more on the pre-continual training approach? So yeah, I think as I said, the pre-continual training is sometimes called adaptive fine-tuning. You may find it somehow confusing. People use different, terminology to describe this. But what is happening basically is this. What do we mean by pre-training? So in NLP, what we mean by pre-training is basically you get a very bunch amount of corpus or level, maybe on Wikipedia data, whatsoever data, very large corpus. For example, let me give an example in Hausa. You can get very large amount of Hausa corpus in terabyte or whatsoever, and you do what we call create a model by doing what we call pre-continuous training. So let me share my screen again so that I can maybe better go back to pre-continuous training. Okay, so yeah, so this is, you have an internet here, we know, and you have corpus. So you do what we call pre-training. What pre-training allows you to train a model on large corpus, and the result of pre-training will give you a model, example of the model such as BAT, and the resultant model such as BAT learns or knows a lot about the language, a lot about the syntax about the language. So if you want to do some tasks, you can basically do fine-tuning. But the other one, which is adaptive pre-training, basically when you have a pre-trained model, you want to adapt the model because the model was pre-trained on different language, for example, language English, and you want to use BAT on Hausa or on Yoruba. For example, let's assume BAT was not pre-trained on Yoruba and Hausa. Because BAT was pre-trained in English, it understands a lot of language stuff. You can teach it more Hausa, more Yoruba. That is called adaptive pre-training, continue. So you continue pre-training and get another corpus, large corpus in Hausa and Yoruba, and continue pre-training it. So that's a basic stuff, but I think I share two resources, one paper on don't stop pre-training and also Sebastian Ruda on, continual pre-training. I think that will be helpful to understand more about this stuff.
Idris, go ahead.
Okay, thank you, Shamsuddin, for the wonderful presentation. My question is with regards to the multilingual embedding. So I went to the playground that was provided on Cohere's website, which I tried to use a little bit of the multilingual embedding to see its capabilities and the rest. So I tried to generate something in English, and it was relatively good. But then when I switched to Hausa, it became a little bit like not as good as English. Let's put it like that. Then I checked to see whether it really supports Hausa language, and I saw that there are a list of 100 languages in which it supports generation and other manipulation. Then so let me leave it at that. My question here is how, because you said we may focus on multilingual settings or just focus on one language. So let's say a person wants to execute a project in Hausa, and then maybe using that embedding give some underperformance. Let me put it that way, not being critical. So how will that affect the ranking? Maybe let's say the ranking, because the idea might have a mark here, but then the accuracy of those type of model on a language, let's say as low resource as Hausa, how will that affect standing on either getting a prize or not getting a prize, so that people will not just focus on English because it maybe is the best represented language on the multilingual model?
Oh, I think that is an excellent question, Idris. Thank you. And indeed, it's very, very possible that the model would underperform on low resource language, which is part of what Shamsuddin have already mentioned, that it is quite challenging, and unfortunately, not a lot of big models out there support very well the low resource languages as much as we would like them to. But we also see that a lot of them now are putting in effort to collect data set and to train this multilingual models as Cohere has done. So I think it would be also nice to look at the size of the data set, per languages that Cohere trained on for their multilingual language to see how much of Hausa was actually represented in their data set. And to your question on like when you generated the when you looked at the embeddings for the Hausa sentences, and you did generate a new text, so it means you're using the generate API, right? You're not just using the embeddings, you're not just looking at the embeddings to maybe calculate the similarity across sentences, but you're actually generating a new sentence. Is that correct?
Yes, I used the multilingual embedding to see the similarity between sentences, but also what I was asking about is the generate function, where you might give a language model like a question to either generate this kind of data for me. If you give it in English, the data like is much more closer to your query than when you give the data in Hausa. So a lot of what was generated before was even in English. Then the language that I couldn't understand, then what I did was to put in Hausa, then colon, then state my question also in Hausa. I was trying to get the model to focus more on giving me something that is Hausa. So I gave it Hausa, colon, then the question. Then there were appearance of something related to Hausa, but then most of it that was generated is English. But then the Hausa started appearing by giving it the right prompt. Yeah.
Well, thanks for sharing more about this. So for this hackathon, again, the technology that we will make sure to judge on would be the Cohere multilingual embedding. So you don't have to use the generate or the classify or the other API the Cohere provides, but it's a nice addition if you did use them. But if you don't use the Cohere multilingual embedding API at all, then it's a huge negative, because this is the technology that the hackathon is focused on. But let's say your solution now uses a mix of these embedding to now to use some other high quality large language model that gives you better generation in terms of like the text generation. Well, you cannot be counted against for that, because also you're meant to showcase a project that has some useful application that is creative. So it's like end-to-end tool. You would use other tools for sure. You would maybe use Streamlit to build an app, or consult some other API to do something to incorporate in addition to using multilingual embedding API to generate this embeddings. So we will look at all of those. Of course, like the judges will consider all that. Again, to mention, if you use all their API, it is a nice addition which would be considered, but the API of focus right now for this hackathon is the Cohere multilingual embedding, and that has to show up in your project. Is that something that clarifies your doubt a bit? I also want to note that we can also, if you are thinking about ways in which we can help Cohere make their Hausa generate function better, maybe by fine-tuning, or like, using the model that they have, and then putting some new sentences to train, to do continual training, like Shamsuddin has said, that would be very helpful, right? Like, we want it to be better on the languages that we care about. And like it's I would say, unfortunately, the world right now is very biased. So that's why, like, a lot of the work that Shamsuddin is doing, Masakani is doing, to curate more data set. My community is also doing in the aspect of like accented speech, to just create more data sets, to have more representation about the languages, the context that we all care about, is extremely important. And if you are able to like improve it, right, in some way, I'm very certain that this is something that Cohere would want to like, you know, fund, to sponsor, to encourage, and also to showcase, and put in their own resource, or to help improve the Hausa representation, or like the generation in within their data set. So it's very, very welcome. It could be that the project that you come up with would be to showcase that this model is not doing well on the language you care about, and then propose a way in which it can be improved. I don't know, some projects like that. So it's useful. It's they can learn from it, they can improve on it, and hopefully it's better for the next hackathon for Hausa, just because of your input.
Yeah, thank you, Teju. I have also another question. Last time in our meeting, you know, I think somebody was asking, the participants, are they, you know, going to develop only applications, or can they develop a model, train a model that they use multilingual embeddings only, or must they develop an application, or they can develop a model that utilize a multilingual embeddings?
Well, at this point, I think if they are able to develop a model like that utilize the embedding as an engine, that would also be very much encouraged. And like it does not have to be just an application that is like fully fledged from end to end. It could be in that direction where it's data science, like you're developing a model. The reason why we were leaning towards the application side of things is because like a lot of these models are not open source, so you have to interact with the API to get it's query based, you know. So that's why we thought maybe thinking about an application where you want to solve, like you have a project in mind, and you want to solve that, could be useful. But if you have a way to still utilize the model, right, to you know, to pre-train, or like to fine-tune some existing model, I think that would be very much welcome. And also, as Roy put on the channel, when someone asked that about the custom model, they also support custom model. So you can custom model in the sense that you can give data and train, customize their model to your own data set, I think. So, and Roy mentioned that you can create a custom model using their trial API key, and he said that there are a ton of open source data sets that is available on Kaggle or Google, which we can use to customize your own model. So I think it's supported. You can customize the model.
So you mean we can customize their model or embeddings using our own data to do continual training?
I think so. Yes, I think it's supported. So that, at least that was what Roy mentioned. But to just clarify, you can also like on our channel, the Cohere AI Hack, not the organizers one, the main channel, just we just do @Cohere and ask the question again, and people from Cohere can let us know. But as of the last time, Roy mentioned that you can create a custom model. And I also like, I've also watched a couple of videos that seems to tend towards that. I have not created my own custom model, so it would be great, like, you know, if Idris already want to test that out, to see maybe if this is something that is doable, and it can share with other hackers, and they can know, and we can, you know, we can also like customize the model to our own context.
Okay, thank you, Tej.
Yes, thank you so much. Is there any other question? We still have two other pre-recording video, which I think is really, it's pretty useful for you to understand what you can build with Cohere and what like how it works. So if you have any other question for Shamsuddin, please go ahead to ask now. Otherwise, we would take a 5 minutes break, and then I will play the pre-recording videos, which in total should be like about an hour. And then we would have an Ask Me Anything session, actually this evening from 6:30, and we can talk more about your project, about, if you're finding or looking for a team, or you want to brainstorm, or you're confused about something. So we organizers will be on the call for 30 minutes this evening, and you can just ask us anything at that time. And we would organize this Ask Me Anything session at different periods during the week, where you get the chance to also still ask us questions as you continue to build, just to help support you and your journey. Someone said they would like to have more info about AfriCente.
Okay, so you can get more info. Let me share. We have the paper of Vicente. Oh, by the way, Teju, she helped us improve Vicente as well paper. You know, you started from errors, right?
Yeah, AfriCente. Okay. So let's take a 5 minute break, and let's reconvene at 18:20. Please don't go anywhere. I will just like play the video, and then we can watch the first video. The video is on building the next generations of NLP applications, and the speaker is Kemi Tijani. This is a pre-recorded video, so we don't actually have Kemi to present live, but the video is I think it's pretty informative. I have watched this video, and I find it informative, and I think everyone should also, watch it so that they can get more insight into how Cohere works, and what it supports. And after Kemi's video, at 5:50, about 6 p.m., we would have another pre-recorded video on how to add AI to your app by Nick Frost, who is the co-founder of Cohere, who also like went through even more applications, more things you can think of doing with Cohere. And afterwards we would just have like a 30 minutes Ask Me Anything, where myself, Mubarak, also would be on the call, and you can just ask us questions. Okay. Thank you so much, Shamsuddin, for joining us today. We'll take a short break now.
All right. Thank you, Jeju. And see you in Kigali.
Yeah, see you soon. Yes.
See you, Chacha.
Ciao. Can you please confirm if you can hear the audio very well? I'll play it now, but I just want to confirm.
I'm really excited to be here today.
Is the audio good?
Yes, loud and clear.
Thank you very much. Okay, I'll wait 3 more minutes before we start. I just wanted to confirm that the audio is playing well. Okay, we shall start now. Can everyone still hear me?
Yes, yes, yes.
Awesome. Okay, thank you.
And I'm really excited to be here today. A little bit about me. I look after, actually one. Okay, yeah. A little bit about me. Can you guys see my next slide? I'm not sure. Okay, amazing. I look after partnerships here at Cohere, but I've been in the tech industry for over 15 years now. It seems like a really long time. But I've kind of seen tech evolve through different kinds of phases from, early days for me, where everything was on-prem and, businesses were hosting their own servers and folks were, building in some outdated languages, to going through the whole cloud revolution, where businesses started to move to the cloud and obviously start to take advantage of new capabilities, which has led to innovation in artificial intelligence, because now you can just leverage some of those infrastructure capabilities in the cloud to actually power your applications or your solutions wherever they are. So I'm a little bit of a veteran in this space, but today I wanted to talk to you guys about kind of the opportunity with AI. And I'm sure we all see it kind of all over. If you're on social media, for instance, on Instagram, you can take a really basic picture of yourself and sort of jazz it up and make it look stunning. And that's one application of AI. Another is, if you watch Netflix or any of the streaming platforms where they're looking at your behavior and your previous sort of viewing history and trying to predict what your preferences are going to be. And then the third example I wanted to share is with Google, who's actually a huge partner to Cohere, where you start to type out your search query and it already starts to recommend options to you, again, based on what it knows about you, your location, your history. And the goal there is to give you relevant information as quickly as possible. Now, the one thing all these examples have in common is that they're all massive tech companies, right? Like for most developers, you say to yourself, well, I see that Facebook is doing that on Instagram, or, Netflix is doing it on their platform, and Google, but these are massive companies. And so how do I use these capabilities without being in one of these companies? And that's exactly what we're here to make possible at Cohere. So first, I wanted to define NLP, because we do use the term, all over in our marketing collateral, and it was on my first slide where I said, we want to teach you how to build the next generation of apps with NLP. But NLP in itself means natural language processing. It's a subfield of AI, and it's primarily concerned with processing and understanding of human language by machines. So think of it as giving a computer or a machine the ability to understand what people say, what they mean, and use that insights to give them more efficient or more useful experiences with machines or with applications, right? And there's some areas already where you start to see AI in action. I know I shared the more sort of consumer-focused use cases, but in a business context, like if any of you uses Gmail, you probably experienced a situation where you're typing out an email and it's auto-completing the sentence or trying to predict what you want to say. You see it in voice assistants when you call customer support and you're getting some AI-enabled bot as your first point of contact, chat bots as well, and then also with basic translations where you can get a text from in any language and then get it translated to another language, just by calling on an API, essentially. Now, I'm sure from those who are not very familiar with NLP, the question usually comes up, it's like, why does this matter? Like, why should I care about this? Like, so machines can understand language. What's the big deal? The big deal is that today, 80% of the world's data is unstructured, and it's captured in text in some database or some data store. And we don't have a great way to actually get insights from unstructured data, because you can think of this as your emails or your call transcripts or chat transcripts, all the communication you've ever made in your entire life. That's, a lot of that's probably sitting as unstructured data in different data stores. And today there's just not much insights or value being derived out of that. When you think about organizations, they even have more data. They have transactional data with each customer. They have reviews, feedback. They have product descriptions and service descriptions. They have all kinds of data that's not structured, that getting insights from would be super beneficial. And so if 80% of the world's data is unstructured and we're not really able to leverage that data today, that means everything we see around us is actually built off of 20% of the data. And I mean, those numbers really excite me, because I'm like, if everything I experience today is just 20%, what is possible if we unlock the rest of it, right? And so that's why NLP is a big deal, because it gives us a way to make sense of that data that we've not been able to leverage in the past. Now, switching gears a little bit, I wanted to talk a little bit about Cohere and, about how you would typically work with building NLP into a product, and then how we would make that much easier and much more accessible for developers. So today, if you work in an organization, and you have to be in an organization because as a developer or a student or someone who's just starting out, you're not going to have access to these resources. And most organizations, to be honest, don't have access to it, because it's really expensive to invest in building out the infrastructure and the team, and then kind of the modeling process as well. But typically what an organization would need to do is, in order to maybe, so I'm gonna use an example application here. So let's say you're trying to build an application that sends a custom Thanksgiving message to every single customer. You don't want something generic. You want it to be personalized. You want it to be based on, something they've told you about themselves. And so maybe you have a field in a form where, and that would be, say, step one, where there's a form field where people tell you about themselves. And this is where the data comes in. And then you have step two, where you basically want to use that to customize, generate a Thanksgiving message. And so you take that form and you put it in a data store, but then you now want to send out that information to be sort of processed and get a custom generation per customer. Like if you wanted to do that today in step three, first, you're going to need to collect a ton of data about, Thanksgiving messages, right? And customer descriptions of themselves. And then you're going to need to somehow label that data and say, well, for customers who describe themselves as this would be an amazing Thanksgiving message for that person. And then step two is you're going to need software to train your models. You're going to need inferencing software. You're going to need a way to evaluate the model that you're building, because you have to build a custom model. And then you're going to start to think about compute, storage. You're going to need a full-time team of machine learning engineers and probably ops engineers and just everyone who's going to keep this model running and updated. You're going to think about safety and trust. You don't want your model to kind of write out stuff that offends people. You think about maintenance. If you want to keep your application up to date, you're going to keep innovating and trying to make better Thanksgiving messages than your competitors. And then, I already talked about the data labeling. And so these are all the tasks that you're going to have to figure out, because you just want to wish people a custom, you want to send people a custom Thanksgiving message. And it just seems like too much effort, right? And so you don't see this happening very often because for many applications, it's just not worth the investment to go build out all of this. Now, switching gears, just showing what it would take to build the same application with Cohere. So think of it as us having built out everything in this sort of bottom section here, like from data collection to labeling, to training, to maintenance, R&D, like we've done that. So that you just, build your form, capture the information, store it in your database or warehouse, and then write an API call to Cohere with that information, and receive a custom message for each customer. Like all you need to do is call on an API. And so you can get this built and get this started like way faster. And so for individuals or for small or mid-sized companies that cannot make this investment by themselves, or where it doesn't even make sense to do that, this makes it possible for you to actually start to leverage NLP within your own applications. I would argue that even for large enterprises, like where, again, they might have the resources, but if it's not your core business to build and manage models, just the way you host your data in the cloud, or you host some applications in the cloud because it makes sense to do that, it might also just make financial sense or like business sense to use a large language model like Cohere's offering. And then I just want to give an example of, a lot of our customers or our users are building products that actually use our models in more than one task. And that's really easy to do. Again, you might have wanted to generate a custom Thanksgiving message. And that's, pretty much a generic task. Like generating a Thanksgiving message doesn't seem highly specialized. And so you can just send that to our baseline models. Now, let's say further along the line, you decided, well, I don't want to just do this for Thanksgiving. I want to build out a whole thing that generates, every time there's a holiday, I want a new message sent out. And I wanted to talk a little bit about my company and my brand. And I wanted to sound like my company because we have a really good marketing positioning. Well, if you wanted to do that later on, again, it would still be an API call, but this time you will be first looking to create your own custom models, which again, super easy to do with Cohere. And so you would bring some of that data about your company or about your, the entities that you want recognized. Give us a few examples of what that brand voice sounds like. And then we can train a custom model so that when you want to call on that, for your future task, you just call on that specific model, and whatever data you share or you use for that training is kind of only accessible within your domain. So like within your business or your teammates, if you give them permissions to do that, we don't share that with other customers. So you're not sort of contributing to a pool that you don't have control over. It's fully within your control who gets access to your data. All right. So I wanted to give a few examples, seeing as this is a hackathon and it's competitive, and I wish everyone would win, but we can't all be winners every single day. I wanted to give you guys a few tips just in terms of how to think about building, whatever ideas you have or you're working on. So this is an example of a flow of, this is actually something that a few of my colleagues built during our internal hackathon week, where we wanted to try to create a factual and contextual Q&A. We called it Ask Jeeves 2.0. For those of you who know what Ask Jeeves is, it's a search engine from, I think, the early 2000s, where you could type a question to Jeeves, who's this virtual butler type personality, and just say to Jeeves, like, who was the Queen of England in 1800? right? And Jeeves would go search that and respond with just the name. And so we were trying to replicate that with Cohere. And so what we did was, well, step one is that you take in the question. So this would be, who was the Queen of England in 1800? And then we decided to do two things. First, on the I'll take you to the top flow and then I'll come back to the bottom, what's happening there. But first, we sent it to our generate endpoint, which generates text. And we wanted it to convert whatever a user entered into a contextualized question. So sometimes users are not direct in terms of how they ask questions. Sometimes they would say, in 1800, there was a Queen of England. Who do you think she was? Like, that's a question. And it would be exactly the same as who was the Queen of England in 1800. For those of us who use search engines, you know that the sort of more wordy option will probably not get you the best results. Like the more sort of surgical you are around typing in your search query, the better results you get. And so what we're doing here is telling our generate endpoint, like whatever a user sends in, no matter how like verbose or like ambiguous it is from like a meaning perspective, try to convert that into a question that's like simple to send to a search engine. So that's what's happening here. You get a contextualized question. And then we take that contextualized question and send it to the search API. So this could be any search API. And then it generates, a bunch of web results. So again, think about if you're searching on Google, you get a bunch of links. But then we actually go into those links and grab the top 3 pages from the results that we shared. And then we kind of queue those here for a similarity comparison. Again, this is another call to a Cohere model, which is doing similarity comparison. Now, I'll pause here to kind of talk a little bit about what's going on in the bottom flow. So while all of that was happening, we also sent another call to generate. And this time, we were trying to create a template for an answer. So think about, if you were having a conversation that sounded natural and you asked the person, hey, who was the Queen of England in 1800? They would respond with something like Queen Victoria. I'm not sure if that's factually accurate, but let's just go with it. So they would say, oh, Queen Victoria was the queen in 1800, right? And that's what the answer should sound like. And so we're using this other call to figure out what should the answer sound like. And once we have that, we compare that answer to what we grabbed from the web pages. Now, the thing about the generate model is that it's really great at generating language that sounds correct, but it's not really factual, right? So sometimes it's lucky and it guesses right, but a lot of the time it's just guessing, right? So it's not accurate. And so that's the whole point of this example, which is to create something that was factual and also sounded natural. And so we take that natural sounding answer and we compare it with the 3 facts that we grabbed. And that's what's happening in this similarity stage. We pull out the most relevant answers or paragraphs that have the right answer. And that would be paragraphs that are most similar to what was generated here. And then we make one last call to our generate model. And what we're saying here is, what we were doing here was saying, well, respond to the user in this tone of voice. And so this could be, respond to the user as a pirate or respond to the user as a clown or whatever. You can use any examples and give it, just give you some examples of what personality you want. And then it would give you the final answer in that personality. And it will be a factual and accurate response to the question that was asked in the tone of voice that you want it to be. So this is a bit of a complex example, but I wanted to share it because I wanted to share the thinking around how do you build out that flow if you're trying to figure out, well, you have an idea for a hackathon project, and this is your first time working with our models or LLMs, you might want to kind of plot this out and figure out, well, what's going to happen at each stage. How many calls are you going to need to make? And then does it make sense before you actually go out and start building? I have a couple more examples, and I think I might be almost at time, so I'll try to go through these quickly. This one is a Magic the Gathering card generator, again, developed by Nick, who's one of our co-founders at Cohere. It's a really simple one because it just has 2 steps, right? So for those of you that are Magic fans, unfortunately, never played it, but I've heard great things. This is a generator that basically takes in a description of a card and then generates, it takes in a character name and then generates a description and then takes that description and generates an image. Now, this image generation is a call to another API, not Cohere's at this point, although we're kind of playing around in this space these days. But yeah, you can send it to any text to image API and then get an image that describes that kind of is a visualization of the description. And so the output here is you have a card that's, winged egg. That was the input. You have an image of an egg with wings that looks super spooky. And I think that's the whole point with Magic. And then you also have like a description. It's a little too small to read, but it's in like this sort of strange mythical language that Magic the Gathering uses for their cards. So this is a super simple one. For those of you who are thinking about Thanksgiving cards, I might have just given you the sort of cheat sheet for that. And then the last one is a recommendation system. Again, a bit more complex, but what's happening here is it takes inputs of what you're currently reading. It tries to understand, like, what are the themes within that. So it's doing a similarity sort of scoring within your history. And it's coming up with like categories that you are interested in. And then it's taking that information and like searching for other similar articles that have the same kind of semantic meaning or that are semantically similar. It classifies them, determines if they're in the same category, extracts the names of those articles, and then it recommends them to you. So again, cheat sheet if you're looking to build a recommendation system. And that was my very last slide. I just wanted to say good luck with the hackathon. I think it's going to be super fun. Can't wait to see what you build. Anyone wants to reach out to me for any reasons, if you're like a business user or you're from a company that's interested in learning more, feel free to send me an email. If you're just a dev and you just want to connect, I'm always happy to chat with people. And you can get all the information you need about our models on our website. If you haven't already been there, it's cohere.ai or cohere.com. And good luck.
Okay, so that was the topic on how you can use Cohere, and you say that Kemi also gave a lot of exciting cool application that you can already start thinking about. And for today, the last pre-recorded video that would have today would be on how to add AI to your app. And I will play that in 2 minutes. Please stay on the call. Do you have any? I said stay on the call. Please stay online or on the current. It's a call, right? Anyway, do you have any questions while I pull that video up? Okay, it seems not like it. Need first. Right. So did any idea come to mind while listening to Kemi's talk? It's not like it. Can everyone hear me though? I think I'm still audible. Hello? Am I still audible? Please, can we have access to just the... Oh, yes, 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 you can have access to all of the videos. So I've actually uploaded this pre-recorded video. Every talk is on our playlist, which I've just put here in chat. So let me share my screen for you to listen to the last one. I think it's pretty cool. It's a talk by Nick First, who is the co-founder of Cohere. And there he also goes into a bit more detail about how the Cohere APIs work, and also what you can build with it, and how you can actually add AI to your app. So this is a tutorial, which I think would be very helpful to you. I'm sharing now. Can everyone see my screen?
So large language models over the past few years have been shown to be super excellent at interfacing with language. So they have some flaws. There's some things they're not good at, but one of the things they're really good at is taking in text and writing more text and using that as a way of having language be the interface into whatever you're building. So the way we create these is we take as much text as we can get from the web, and we turn that into a data set. And the data set just looks like about we'll have a bunch of examples of, like, maybe we'll have a page of text, and we'll give it the first half of that text, and then we'll train a neural net to try to predict the second half. That's it. We just do that over and over again on this neural net until it gets very good at predicting what text is likely to come next. The reason why I talk about this when explaining neural nets to people who are just getting into the field is that it can often feel like magic. Like when you're talking to a chat model or you're sampling from a transformer, it can feel like you're talking to some crazy magic thing where you put in a question and out comes an answer, or you give it a command and out comes something else. But it's not. It's really just a probabilistic model of sequences of text. So you write, "Hello, how are you doing?" And it's quite likely that you would say "today," "next," or something. And so that's what the model does. I see a question from Zoya saying, how much data do you need for this to be effective? There's actually two answers to that question. And that's because training these models comes in two steps. The first step is baseline training. So we just train the model to be good at language in general. And how much data do you need for that? A huge amount. As much data as you can possibly get. Cohere, like, we train our baseline models off of data taken from the open web. So we feed it, like, all the open source books we can get, and any website that's being hosted that a bot can crawl. We try to get that data and process it so that we just get the text from that website. So really, like, terabytes of text in the end. And then there's a second step, and that second step is where we fine tune the model to be good at following instructions. And that's what goes into creating our, like, command models. And those are really the ones that we're going to be talking about today, because it turns out those are way easier to use because they've been fine-tuned to be specifically tailored to people using them. So that's the thing.
I want to say, like, one thing. Presumably you are here because you're a developer and you're like, well, maybe I could use some AI in my apps. Let's see how this works. So while we do talk a lot about some specific machine learning concepts, you don't really need to understand all of them. And if you're lost, that's totally okay. At the end of the day, you just need to figure out, what could this be useful for in my app? And how do I do it really, really easily? And the other thing to understand is basically what we have is these models that have looked at Wikipedia, they looked at Reddit, they spent a lot of time browsing the internet and reading text on there, and what they've come out at, what they come out with out of that exercise is now they kind of know how to sound like a human. So the model Nick is going to talk about now is a model where you can ask it and it will think about, well, how would a human answer this? And it will produce some text that sounds human when answering that question.
Yep. Yeah, cool. Okay, so let's flip over to, oh, I see another question from Brian. Is this similar to how Gmail now gives you suggestions? Yeah, it is similar. Yeah, so Gmail is doing like, as you're writing, it's using machine learning to predict what a likely completion of that would be. And then if it thinks it finds a very likely one, it shows that to you. So yeah, quite similar, except we're using significantly larger models trained on different stuff. I'm pretty sure the Gmail models are like smaller in scale, and they're more restricted to that like one use case, whereas the ones we're creating are just general purpose command following models. Cool. Okay, so I'm going to share my screen, and I will share. So this is our website. This is a playground that we've created, and we created this so that you can play with the models and see what they're good at, and you can figure out a prompt that works for the task you're trying to solve. And then you can export the code. So if you're just beginning to develop on this, I highly recommend going to the playground and playing around to figure out what the model is good and what the model is bad at.
How do you reach the playground?
You reach the playground by going to our website, go here, AI, and then clicking Get Started, and that brings you to the dashboard. This is where you can like log in and see your API keys and billing and team and all. Look at the model cards, and then click Playground, and that will bring you here. Thank you, Michael. Okay, cool. So this is a prompt I wrote. I wrote a prompt that says, write a list of 5 names for a really nice cat. And if I click generate, I will generate, here are 5 ideas for a really nice cat. Snuggles, Blanche, Cuddles, Grin, and Puff. Okay, cool.
Can we try a terrible cat?
Yeah, so let's see what happens if I say a really terrible and mean cat. And if I generate from this, it will say, Chronicus Maximus, Snarticus Nebulus, Sedaticus. Great. All right, cool. Let's go. Grizzware Grinder. Okay, let's try again. So really mean cat, Scrapper, Scratch, Scrounger, Scrummer. Yeah, anyways, the reason why I do this is I'm demonstrating 2 things. One, like, it's listening to the language, and it's because it's been fine-tuned, it's because it's trained on the baseline web text and then fine-tuned on what people would expect. Even subtle things like this, like saying a nice cat or a mean cat, like you get affects the output, and we can see that it's aligned with mostly what we'd expect. This isn't super useful, right? Like I don't in terms
Objection.
Okay. But like in terms of what you guys want to build, like it's probably not often that you're going to come into building an app where you're like, what the user needs is, an infinite number of names for a mean cat. It's much more likely that what you're going to come up with is, something that like solves a problem for you. So for instance, let's imagine Michael and I are talking and we have a chat that looks like this. Michael,
That's not how you spell my name.
In this example, it is. I just got this great cat. And then Nick says, so cool. What did you call her? And then, fine. And then Michael says, her name is Mel. And then Nick says, what kind of a cat? So imagine we have this chat and I want to extract the name of the cat in here. So if I say like extract the name of the cat mentioned in the chat below. And now I'm going to sample from this model. Oh, oops. Oh, sorry. Use our bigger model here because this is actually getting a little complicated. So, okay. This is like, imagine you're making a chat. You have a chat bot and you want to always be reading if somebody's mentioning a cat or something. And so we could grab the history of the chat pump it into this model, which will read like this is again the prompt. That's all we're giving the model. And out comes the name of the cat.
She's a great cat.
Yeah, this is the name of Michael's cat, by the way, and she is really a lovely cat.
I'm gonna add pictures into the slides.
Sure. Yeah. So by being careful about what we're giving it, we can get behavior that's actually actionable for some application to do. Like you could imagine if you want to write some like bot or a Twitter bot or something, or a Discord bot that is always in a cat themed Discord, and anytime a new cat is mentioned, you want to like take some action or something, you could write a prompt that would look like this. So what I've given it is some priming to say what it's going to do. Then I've given it the chat, which you would replace with the history that you were pulling from some app. And finally, you give it an extra prompt just to make sure that it does that exact thing. But we can take this a step further. And instead of just doing a chat name, here's a really long prompt that is like very specific. So this is a prompt that says, it's very similar to the last one. It's extracting something, except instead of it just extracting a single chat name, I'm actually extracting a full JSON object that gives me a whole bunch of information about a transcript. So here I say, extract the following information from the phone conversation below. Here's 7 things I want the model to extract. I have some details about what it should look like make sure the fields 1 to 6 are answered in very short sentences. 7, I want it to be a detailed summary, so I didn't want to say 1 to 7. Then I say, please answer it in a JSON machine readable format. And I tell some things about what the JSON should be. It should have a results object. I give it the phone conversation. And then I put JSON : and I extract from this. And here we get a fully properly formatted JSON object. Here, I can show you the whole thing here. That shows you the results, the reason, accident, cause, pothole, driver's names, which are in a list and properly formatted, insurance number, location, car damage, and here's a summary of what happened. So you can imagine if you were an insurance company and people were calling you and you wanted to make sure that you got all their information correctly, you could take the transcript of that call, pass it through this prompt where you replaced this transcript with whatever the transcripts you got, and then you would just get this JSON object out. And so that's suddenly like super actionable. So the point here is you can take these general purpose models, which just are trained to follow commands, and then give them a prompt, which gives them something really trying to figure it out. Sorry, realized that. Oh, yes. Okay, great. So I realized I hadn't seen the chat, but now I realize it's all just people saying it's about cats, and that's lovely. The rest of the talk will not entirely be cat-based. Cool. So let's pass it over to Michael to look at what this looks like in code.
Okay. Can you hear me well? Because I'm speaking into Nick's computer. Can someone type in the chat that you can hear me? And if it's
yes.
Okay, great. So we're going to start in the playground because that's where you usually start. I'm going to share my screen. Here we go. Well, first of all, no, we're not going to start in the playground. We're going to start here. This is a picture of my cat. This is Mel. Right before I got her, she's the best. Moving on to the playground. The playground is a website where you can just kind of toy around with building the right prompt to do the thing that you want. So when you visit the playground, you'll see a bunch of different things on the top: generate, embed, classify, and you won't see this beta, but I see it because that's something I'm working on called summarize. Generate, embed, and classify, those are all the different APIs that we offer at Cohere. The one Nick has been talking about today is called generate. I was like, how do I hide this? There we go, it's hidden. It's called generate. And generate, like we've seen before, you give it an instruction like, what's the best name for a cat? And then if it says something that's not Mel, I quit. Let's find out. Oh, it's using the wrong model.
Actually, this is a good moment. So the model he just pulled from was not the command following one. So that was just a model that's good at general purpose text, not at following commands.
I'll go into this in a second. Okay, great. The best name for a cat is one that you and your family love and fits the personality of the cat. Some popular cat names include Luna, Boone, and Charlie.
That's great.
All right, this is not an offensive answer. I'll accept it. I stay. What's going on here? So we have the input, the prompt. We have the output, which is what the model responded to my prompt with. And we have all these parameters on the right. Let's kind of look through them and see what's going on. Well, the first one is the model. The model, you can think about it as essentially like who's answering this question. Is command medium nightly answering this question? Is command extra large nightly answering this question? All these different models are the ones we trained on different amounts of information. And if it's trained on less information and it's named something like medium, it means it runs a little bit faster, but it knows a little bit less. And if something is called extra large, it means it knows a lot more, but it's a little bit slower. So it's kind of up to you what works best for you. We're going to look at the command nightly command model, command extra large nightly. Let's kind of think about what the name means, command. Well, command are specific types of models that not only know a lot of information, but you can also talk to them with instructions. You can tell them like, what's the best name of the cat? Or write me an essay that I promise not to plagiarize. And it will do that for you. Other models work differently. So we're only going to focus on command because this one is really intuitive to work with. And the extra large next to it, like I said, just means it knows a lot of information and it runs a little bit slower. Nightly means we're updating it very, very frequently, which means from today to next week, it might get much, much better. Okay, cool. So we selected command extra large nightly. We have a prompt. What else can we do? Well, we have here the number of words, or specifically the number of tokens. Models don't really speak words. They speak in tokens. It's kind of weird to think about, to wrap your head around. A token is approximately one syllable. That's kind of how I think about it. But at the end of the day, what you want to say is like approximately how many tokens or how many words do you want to generate? And if you set something like 10,000, doesn't mean that that's how many it's going to make. It just means that's up to, that's the maximum number of tokens it's going to spit out. And then we have randomness. If you want something that predictably spits out the same thing every time you call it, you want to set randomness to 0. Or you could set it to something crazy and then, go to town. It's your life. All right, so let's play around with this. Let's say, what's the best name for a cat? Let's set it randomness or temperature, what it's called scientifically, to 0. Let's see what happens. Sure.
One thing to note is that if you have a really high number of words, it will take longer for the model to generate because it's going to try to generate that whole thing. So,
all right. There's no one answer to this question, as different people may have different opinions. If we run this again, hopefully the answer we get is either going to be the same or very similar. Let's see what happens.
So for the extractive case, like the JSON stuff that I was showing you, you almost always want to use a really low temperature because you don't want it to be creative. You just want it to solve the problem. So yeah, you're right. Exactly.
So if you want to set the temperature or the randomness to something high, it means like, yeah, let me generate one. Let me generate another one. Why not? Something different. But if you always want something that predictably gives you the answer, set the temperature to 0. And we're using the words temperature and randomness interchangeably. Okay, cool. So now we kind of figured out our ideal prompt. What's the best name for a cat? Actually, is this the ideal prompt? Probably, let's say it is the ideal prompt. How do we plug this into our application? Well, right here on the top right, there's this view code button. And if you click it, it's gonna give you a code snippet. We have language-specific libraries. We have one for Python, for Node, for Go. You can also just hit it like a regular HTTP request. And you'll notice that it populates quite a lot of information here. Well, it chose the model that you selected on the right. It included the prompt, excellent. The maximum number of tokens, temperature, but then there's also like all this other stuff, K, P, frequency penalty. Those are all optional parameters. They show up on the right here under advanced parameters. You can just copy this code snippet and not worry about them. You can also remove them. We have defaults for them. But just so you know, don't be terrified if you see all the stuff that you don't know. They're just like additional ways to control how the model behaves that we're not going to go into right now. Okay, and what does this look like in code? So I'm going to jump into my code editor. Over here, I set up a little node server. I'm assuming that you know a little bit of JavaScript. If you don't, that's okay. We're not going to spend too much time in the nitty-gritty details of JavaScript. But basically what I have here is a little server. And right now, if I save it and run it, let's try that just to make sure it works. Going to hit my server. and it says, hello from Michael and Nick. Why does it say that? Well, because that's what I'm sending back. Let me not send that. And instead, we're going to use the Cohere library. First thing we're going to do is we're going to import it. Over here, we have constant co, and then required Cohere AI. Why co? It's just cute. We like calling Cohere co. So anytime we interact with Cohere, we do it with co, with things like co-generate, co-embed, and co-classify. So the API we're working with is generate. So our call is going to look like this. It's going to be like co-generate. Let's see what's inside of co-generate. We have our model parameter, which we decided is going to be command extra large nightly, the maximum number of tokens to generate, and then the prompt. And the prompt, I pretty much, you can copy paste it from the playground. Over here, I came up with a different prompt. It says, come up with a title and a synopsis of an episode of the TV show Friends that doesn't exist. Let's see what it does. So I'm going to save this and run it. And here we go. I find that these episodes often can be quite risque. Let's see. Is your things might be terribly, terribly broken. Nope, they're not. It's just command extra large is on the slower side. Okay, well, let's see the title. The one with all the resolutions. This is sick because all the episodes of the TV show Friends start with the one with or the one where. So this is relevant to Friends. Synopsis. It's New Year's Eve and the gang is getting together to celebrate. Each one of them has a different resolution for the year and they all want to stick to them. But will they be able to? I want to watch this. Okay, so this is sick. You can imagine you could build a cute app, web app that, whenever people visit it, it spits out a new episode of the TV show Friends and tell you what happens in it. And then later you could write another prompt that says, given this synopsis, what happens to Joey? And then it would maybe come up with a story for what happens to Joey. So that's the API we've been talking about called Generate. I think it's really, the reason we start with Generate is because it's very intuitive. You can kind of talk to it and it talks back. But also it's one of the two main foundational technologies that power everything we do at Cohere. We have generative models and we have representational models. Generative models power APIs such as Generate. Representational models do something else. And I'm going to let Nick talk about that.
Yep. Cool. Thank you, Michael. Okay, so I'll talk about the other side of things. So we're going to talk about the representational models. So the generative models take in text and write more text. That's what they do. They just take in text and they write more text. And what kind of text they write is dependent on what model you're using. So using the command model, it takes in text, which it expects to be a command, and outputs text, which it thinks is the completion of that command. If you're just using the baseline model, it takes in half a sentence and writes the next half of the sentence. That's the generational. The representational takes in text and creates a vector. A vector is just a list of numbers. So it just creates, it takes in text and outputs a list of numbers that represent the meaning of that number. If you're not familiar with ML stuff, that might not be obvious to you why getting a list of numbers that represent text is useful. But it is for a number of reasons. And I'll show that by first sharing my screen. Actually, Michael, can you stop so I can?
If I could figure out how to, that'd be, oh, there we go. Big red button, why not?
Okay. Okay, cool. So this is fun. This is our embedding model. And this is our playground for our embedding model. So here I have a whole bunch of pieces of text. Let me zoom in here a little bit. A whole bunch of titles from subreddits. This is like subreddit titles about something, various things. Greenland permanently bans oil and gas exploration. That's terrible. No, that's great.
That's great.
Yeah, that's great. Anyway, so these are titles from subreddits. And what I'm going to do when I click run here is instead of taking in text and writing more text, I'm taking in text and getting a vector, and then I'm showing that vector on a two-dimensional grid. So now if I look at two things that are close together, that means the model thinks those two things are similar. So for instance, here's two different titles. Non-sufficient fund fees are ludicrous and our government should have outlawed them years ago. And here says, Another title is, are you annoyed that taxes are not built into price tags in Canada? Non-sufficient fund fees are, so all of these titles are about like finances and taxes. And so the model thinks they all kind of mean something similar. Over here, what is this? Oh, these are like relationship advice things. That's often spoken. Reddit. Over here. Okay, so these are all like, this is a little section of homes that we do in classification with this. We can train downstream models for all kinds of things. We won't talk about that. We're just going to talk about using this as a way of understanding, like, are these pieces of text similar? And that's some. And what's right for your like application is great advice. So try both. A new model that does multilingual stuff. So I think we won't talk about that today just because the talk is about English, but we have this multilingual model, and that means you can put any language you want in here. You can put French and English, and there's like 100 different languages in this multilingual model. And if you've said like, hello, how are you? Or if you say konnichiwa, like do desu ka, like in Japanese, hello, how are you? The model will think that those mean the same thing. So that's a very cool aspect of the model. But I'll pass it over to Michael to show what it looks like to use this embedding model in code to solve problems. Cool.
Okay. So there are two questions in the chat, and I'm going to address one of them. I can try to address both of them. One of them is about OpenAI, and they also have embeddings. They also have generations. Why would you use Cohere versus OpenAI? And the answer probably is try both and see what works best for your use case. Because they're trained differently. There's also other reasons like pricing and how well like how fast it runs and stuff like that. Nick maybe has a better answer.
That was a great answer. Yeah, they're a provider of models as well. We have a slightly different focus than they do. We're not an AGI company. We're not interested in creating artificial general intelligence. We're interested in making models useful today. That's one of the reasons why we've invested in the like multilingual embeddings. That's like not necessarily a step towards AGI, but is a super useful business application. But yeah, no, Michael's advice of trying both and seeing what works for you and what's right for your like application is great advice. So try both.
The second question is, how are people using these APIs? What are some real world cases? Well, let's talk about it. I have a slideshow for this.
Oh, that was right. I'd say really set you up. That was a
It
great
really
segue.
set me up. I'm not sharing my screen. Let me share my screen. Okay. I'll start the slideshow. First of all, this is my cat Mel. If this doesn't answer your question, I don't know what will. Secondly, imagine you're in a band. Imagine you're in a band with this guy. And imagine your band is called Good Kid, and you've been doing it for 8 years. This is completely hypothetical. Imagine you're on tour and you're traveling the world, you're playing music, you're having a blast. This guy on the top left is just having a day. All these people on the right also having a day. And meanwhile, on your band Discord, people are asking you questions. They're like, how'd you guys meet? How'd you all meet? That's neat. Have you met through programming or not? How'd you all meet? And you're here, you can't answer those questions, but the questions that keep coming and they're very similar. Well, what can we do to help the situation? This is before I joined Cohere, and this is partly why I joined Cohere, because we kept building these cool bots using Cohere for our band Discord. I know Nick through university, and we've been in a band together for a long time. And I got to work with Nick on some of these bots, and I saw that it was really cool, so I ended up joining the company and working on the underlying technology. So yeah, how do we address this? Well, on our Discord, we built this bot that recognizes frequently asked questions and then can answer them using a response that we created for it before. So I can probably show this to you in real life. Here's Ask the Band. And yeah, somebody asking questions. Well, this is actually an excellent example of it failing. Somebody says, how did you guys meet Lovejoy? Lovejoy is a new band that the model doesn't know about, but it's like, well, that sounds similar enough to how did you guys meet? And then it pulls out the answer to that question. But a lot of the time, if I look up this question in the search, let's see, that's this one. Yeah, have you guys met through programming or not? And it's like, yep, this sounds like, how did you guys meet? And then it gives you the answer. So I figured this is a useful scenario. It happened in our Discord. In general, a frequently asked question bot sounds reasonably useful. So I might show you how to build one. So I'm gonna go switch to the playground. Actually, I'm not gonna switch to the playground. I'm just gonna look at you. I'm gonna look you in the eyes and I'm gonna remind you that at the end of the day, Generate understands the text and can spit out more text for you. Embed understands your text. So basically you have text as an input. It will extract the meaning of that text and represent it as a bunch of numbers. Why is that useful? Well, because numbers can be compared to each other. So if we have text 1, text 2, extract the meaning of them, get the embeddings. Now we can compare the embeddings and we can tell whether the two texts are talking about the same thing. So if someone says, where'd you guys meet? And what's your favorite cat name? We can extract the meaning of those, compare, and realize those are actually not that similar. So probably not the same thing. But if someone says, where'd you guys meet? And did you meet in university? Extract the meaning, compare. Yeah, similar enough. Run the bot. So that's kind of what I wanted to show you. Before I jump into the code, are there any questions?
There's one question, Nasai, about ethics and around safety usage, and you've linked to the page that we have about this. So this is more just more to talk about the generative stuff. The safety applications for embeddings are like a little clearer cut, I think. But the chat stuff, yeah, there's definitely like misuses of language models. We have a terms of use, and we spend a lot of time pruning the data and getting our fine-tuning data to try to get the model to be aligned with the values of the company so that we're like happy with the output. So like, yeah, essentially, like, how do we address this? We take a data first approach and we spend a bunch of time making sure that the data goes into the model is like stuff that the company is pleased with. That's like an ongoing effort. And I think we'll be working on that forever because it's an important thing. And yeah, there's always improvements that can be made. For the embedding stuff, it's significantly more restricted. There's not very many misuses of an embedding model. Although it is, we still like to make sure we run, look at what's coming into the model and try to have an understanding of what people are using it for. Yeah, cool. Okay.
If you have any questions, pop them into the chat. Nick is watching the chat and let me know if something comes up. I'm going to switch into code. So what we want to build is we want to build something that can, given a question, figure out if it matches any of the frequently asked questions. So I'm switching into this frequently asked questions JavaScript file. It's not 3 lines of code, it's about 80, but they're all pretty straightforward and I'll explain them. We're going to start with having a collection of Q&A. So right here, I prepared exactly the file that we ran our bot with. It's just a bunch of questions and the answers we prepared for them. So for example, people really want to know what's our favorite musical. Well, mine is Cabaret and Chicago and Producers and Sweeney Todd. And the other guys, who cares? So if somebody asks something about musicals, we should be able to find this question and then use the answer for it. So let's see what we got. This is my file. I'm going to go ahead and make sure that this works before we try running anything else. This is frequently asked questions that. Switching to Postman and embed, and let's go. So I'm sending in a question, how did you guys meet? And it's responding with hello from Michael, Nick, and Kate. Okay, we can do better. We can answer this question for the user. So let's see what we got here. So the first thing we're going to do is we're going to instantiate Cohere, and we're going to use this Q&A JSON file. So really, and the rest is just like me starting the server, nothing to do with Cohere. There's this function right here, get similarity score. It's very, very mathy, and I did not come up with it. I basically went to our website and I copy pasted this function. Given embeddings A and embeddings B, it can compare them and it can spit out the score. It's kind of annoying that you have to copy paste this function into your code right now. This will get better literally in a couple of weeks.
Yeah, stay tuned. Stay tuned for that.
But for now, you know that there's this function that given embedding A and embedding B can compare them and can tell you how similar they are. Great. What I did is I grabbed just the questions from our frequently asked questions list, and then I embedded them, which means now for each one of these, I have an embedding.
Which again is a list of numbers.
It's just numbers.
List of numbers.
So I have my questions, and now I have my embeddings for those questions. Next up, I'm going to take a user question. So this is me grabbing whatever somebody passes in the request. So in here, I have this question, how did you guys meet? And this is going to get stored in the variable question. Then I do co.embed, and I just pass in a list of text, which in this case is just one text. It's my question. I get the embeddings back, and I store the question embeddings right here. So now I have question embedding, and then I have all the embeddings of the frequently asked questions. Now the only thing I need to do is find the best match. So here I call this find matching question function that I wrote right here. It just goes through all of my frequently asked questions. It calls get similarity score, grabs the score, and then finds the question that has the highest score, and then returns the index and the score for that question. Great. So we found our best match. And yeah, we can now send that question back. So let's do that. Let's run this. And Nick, you ready? Where'd you guys meet? Okay, so what it did is it found the most relevant question. And the question is, where'd you guys meet? And how'd you start the band? And the score is 0.71. I'd say that's a good similarity, probably means it's this question. So how about now, in addition to returning the question, we can also return the answer. So let's do the answer. OA. Let's see if this works. The answer, Jacob and David met in high school. The rest met in various ways at the University of Toronto. Jacob and Michael met in German class. It's true. I don't speak German. Question, we can also return the answer. So let's do the answer. And then let's do, what do I call this? QA. Any question from anybody can figure out if it's one of the frequently asked questions and give an answer for it. I think it's pretty cool. Works. The answer, Jacob and David met in high school. The rest met in various ways at the University of Toronto. Jacob and Michael met in German class. It's true. I don't speak German, kind of sucks, but I have a minor in it. Michael and Nick met in computer science classes. It's true. Nick and I met in a computer science lab. He was very smart. I was smiling a lot. It was a great time. Yeah, and there we go. We wrote a bot that, given any question from anybody, can figure out if it's one of the frequently asked questions and give an answer for it. I think it's pretty cool. And for our band,
one of the things on that bot that is to like productionize it, we had to add a few other things. One of them is a call to classify to figure out if what is said in the channel is a question. Because sometimes if you say like, oh, I don't want to call the bot if the people are just chatting. I don't want it to interrupt. So there's a call to code classify. We won't explain that, but that's an endpoint that exists as well. You can give it a few examples of labels as you want it to classify, and you pass the message in and classify it. The other thing we had to do is set a threshold to say, like, at what level of similarity are we comfortable returning the result? The bot is going to respond. We respond when we're like very confident that this is the right answer. Or do we want to respond when we're like kind of confident? And that's just a trade-off of like how annoying you want the bot to make you. Otherwise, which integrates with the Discord API, but because our API is always just it's a network-based server, and you get the response back, it's very easy to productionize this stuff. That actually, I see there's a question from Alex on what are the pros of using a proprietary fine-tuned model like yours over open source. So there's a few of them. One of them is that we don't APIs around that to use it. So like our models are always hosted. We have good SLA metrics. We're constantly serving the biggest, best models we can. And if you can ping that via a network and go to production very easily. So if you download some large model and you want to host it yourself, you need to worry about like what GPUs you have. Do you have enough to handle the traffic? Things like that. If you want to just, like Michael and I a while ago made a little fun website that generated Magic the Gathering cards with our API. And it got on the front page of Hacker News and like blew up. And we never worried about the load once because that website was just pinging Cohere's servers, and Cohere's servers scale and handle it. That's like the hosted side of things. There are companies out there that like host GPTJ or Neo, those things. The other answer is like, the models are just like, they're just better. They're bigger, they're larger, we train them for longer. When we evaluate our model compared to open source stuff, we're significantly beyond where they are. And that's especially true now that we're fine-tuning on human feedback. So now that our models are like trained not only just on base text, but then fine-tuned on data that we're specifically curating to make them useful. I imagine over the next little bit, open source will continue to be an important part of the NLP community. And I think that there's gonna be some great small models that will come out of that. And if your use case requires like something that you can host yourself and that a small model is good at, then open source would be a good place to look. If what you need is a hosted solution of a state-of-the-art massive model that's prohibitive for people to train, I think it's probably going to be in companies like us. But always good to look at what's out there. Yeah. Cool.
Yeah, I think there's only two more things I wanted to say.
Okay.
Thing number one is that, like, we talked about generating text and we talked about understanding text. And those are the two underlying technologies that we work with at Cohere. And then what we do on top of that is we build APIs that take common use cases of those technologies and make it as easy as possible to just use them. So, for example, you saw the beta of the summarize endpoint. This is something we're working on right now, and will be out in the world sometime soon.
You just leaked it.
It will never be out in the world.
Okay.
Yeah, the goal is, look, people summarize text very, very frequently. So you should be able to just say code.summarize, pass it an article, and it will spit out a summary for you. This is cool because this solves real life problems for people. And what my hope is that you will look at these APIs and be like, wait, this reminds me of like an idea I had for an app, or this could be useful in my app. And then you will start using it and you'll tell us, hey, I've actually been using your API like this or like that. And then maybe we'll just build a dedicated endpoint for other people to do something similar to what you're doing. So I strongly invite you to join our Discord if you're not in our Discord, because we hang out there all the time. And if you run into problems and you have any questions, you can just tag us and ask a question. We'll help you get set up.
For sure. So you had two things. Was that both things?
That was thing one.
That was thing one. Okay, what's thing two?
Thing two requires remembering thing two.
Okay, I'll answer this question. You remember thing two. Alex, you have another question about a huge complaint about existing LLMs is that they hallucinate or make things up. Have you guys thought about how to circumvent factual errors? Yes. Okay, so an important note about language models. They have no notion of truth. They have no idea what's true or what's not true. They're not truth models, they're language models. They're just models trained on the web first, and the web has all kinds of true stuff and all kinds of not true stuff. And it has things that were true a few years ago and are no longer true now. And it has things that were never true and never will be true. So yeah, they're not goods. They're not oracles of truth. Like, I do not recommend going to a language model and asking a question that you want the truth from. I recommend using a language model as an interface for other sources of information and other source of truth. So yeah, I have an open source project called Grounded QA, which thank you for posting in the chat. And that's using a language model plus the embeddings stuff that Michael was just talking about. So that, and plugging that into Google search, and Google search acts as like a decent source of truth. So it's, when given a question, Google searches something, finds relevant text using the embeddings stuff that Michael just explained, grabs that relevant text, and then tries to answer the question based on the text.
Like, imagine for a second that you are an engineer, you're a developer at a company, and you're on call, and a 500 pops up, an error. And you're like, what do I do? You could just go and ask Cohere, I see a 500, what should I do? It will give you maybe something, but what you could do instead is find the relevant section of your on-call run book using embeddings, like I showed you how to find a comparable frequently asked question. Now that you know the section of the document that's kind of relevant, you can plop it into your generate prompt, and you can say, knowing this information, I have a 500, what should I do? Mm-hmm. And now it will reference the information from your source. Mm-hmm. So kind of what Nick was saying is, if you say a factual question, how many children does Joe Biden have? Our model could invent you how many children Joe Biden has, mm-hmm. or you could go find the information on Google. It probably will be an article or a paragraph or something. You can plop it into the prompt and say, like, knowing what you know from this, how many children does Joe Biden have? And it will tell you the correct answer.
Yeah. Yeah. So that's where I think like the real value add from language models is. It's in working as interfaces. As we go down the like fine tuning on human feedback, we get closer to the like, you can ask it things and get useful information out of it, because we're, then when we collect data for fine tuning on command, we're asking people to write things that they think are true. And so it's like it's more likely to output the correct stuff. But, for instance, we collected some data for command if you asked who is the prime minister of the UK, well, that's changed a lot in the past few months. And so there's sometimes when someone might have put in one thing, a few weeks later, they put in something else. So even there, even though everybody's trying to give true information, the truth is literally changing as time goes on. So yeah, I think language models, they'll ultimately be interfaces for databases that are sources of truth and not sources of truth themselves. Cool.
It's just in, there's a new prime minister of the United Kingdom. Congratulations.
Congratulations. Oh, wow. Okay, another question says, I'm a student here and I was wondering how you guys use statistics to make these models predict better. A secret for you, in some ways, it's all statistics. In some ways, in the end, what these models really are statistical models of sequences of language. So you can imagine a really, really simple statistical model for predicting language. Imagine if I took a book and I counted all the occurrences of two words next together. And I noticed that every time I say hello, 80% of the time it was hello there or something. So I just made a statistical model that would take the first word, look at what the likely words that came next were, and then predict one. That would be the first statistical model of language, and that wouldn't be very good. But now we just, instead of having a lookup table, we replace that with a neural net, but otherwise we're doing the same statistics. We're just trying to learn the relationship between sequences of words. So yeah, it is just all statistics in the end.
I remembered the second thing.
Oh yeah,
I'll let you address the question after. The second thing I wanted to talk about is that we trained those models. We trained them on a lot of text on the internet. And that means the answers it's going to give you is it's going to try to sound like what it's on the internet. However, if you want to, and if you have a lot of information, you can train them additionally on top of that on your information, and then it will really, really try to sound like the kind of stuff you taught it with. So for example, if you are building a chatbot and you have a bunch of examples of what a chatbot should sound like in your application, we call it creating a custom model or fine-tuning. You might have heard Nick talk about fine-tuning. It means take a default out-of-the-box Cohere model that's seen Wikipedia, Reddit, and all this other stuff, and now really show it the information that you want it to start spitting out and train it on it. So it's going to start reading all the information that you showed it. It takes a couple of hours. I can show you later what it looks like on our website, but basically you go to the dashboard, there's a section about models, and you can click Create Custom Model. And then you'll upload your files, and it will start this fine-tuning process, at which point it will be done. And now it will heavily weight what it saw in those files as opposed to Reddit and Wikipedia and whatever else it saw before. So this is a lot of the time really useful if you're finding that the model kind of sounds generic or it doesn't speak in the right tone of voice or something. You can train it on your personal data, and then it will sound more like what you want it to sound like.
Cool. Oh yeah, I see why you. Yeah. So yeah, I think the reason why Michael wanted to talk about the fine tuning is that, Alex, that does get to your question. So if you're fine tuning with us, you upload our data set that goes to our servers to fine tune, but then we don't use that for creating the base model. The base model is only the stuff we get from the open web, and then the data that we create for fine tuning for the command following and for chat stuff. So no, if you upload a fine-tuned data set, we're not putting that into the base model. We wouldn't want to. It's most of the time when I've found people are fine-tuning, it's a really specific use case. It's their data, it's for them. We have stuff in place that we won't fine-tune on it, but mostly what we're looking to get is really generic web text, then really specific command stuff. So yeah, you fine-tune, that's never added into the base model.
There's another question about how ChatGPT, when you talk ChatGPT, instead of waiting, get the answer, you start getting the answer word by word. And the question is, do we do that? And the answer is not yet. Do hold your breath.
Wait. I was under the hood, yes, it's the same thing. These are called auto-regressive models where they predict one word at a time. Our API right now, we don't return a word at a time, because that slows the whole generation down. So if you want 100 words, it's going to be faster to get all 100 words and then return them to you than it would be to get 1, 2, 3, 4, 5. So when we built the API, we prioritized just getting the whole thing to you and returning it. most production use cases like the JSON extraction or summarization, I find that's normally what's best for people, but a lot of people have been asking for it. And so we've been working on the streaming thing as well.
Yeah, so the streaming thing, while it takes a little bit longer to get the generation,
To make the UX
it's nice, or if you're building a UI where the user is seeing stuff appear as it gets created, it's a nicer experience. So we're gonna do both.
Yeah.
Why not both?
No, why not both? No.
Okay, well, thanks for staying till the end. And this is the last video for today. And also, it marks the end of our 3 days workshop series. The hackathon starts officially tomorrow, and you have until Sunday at 8 a.m. to build, to hack, and to submit your solution to us. On Saturday, on the 6th of May, we would also have a 1-hour live stream video. This is not pre-recorded. This is going to happen virtually by Sarah Hooker. There she will talk about the Cohere for AI lab that she's leading, and some of the projects that they're currently working on open science research. So the topic of our presentation would be Cohere for AI Open Science Research Project, Multilingual Instruction Tuning. So this is again going to be on the 6th of May, next week, Saturday, from 11 to 12 p.m. And it will have happened virtually. We will live stream it also on YouTube. So thank you. And now we move to the Ask Me Anything session. If you have any question, you can ask. If you just want to chat about your project, this is also a good time to talk about them.